In this video lecture, we want to give an introduction to all the additional classes and packages automatically provided by the Java programming language. Okay, let's get started. So as we've already seen, every class in Java has its own API, which tells the user two things: how to create objects of that class using its available constructors, and how to use those objects using all its available methods. All of the APIs for all of the classes in Java, taken together, constitute the Java API, or the Java Class Library. The Java API gives a listing of all the available Java packages, which will be defined in a moment, a full list of all the available Java classes, and a class API for every such individual class. There are a couple different ways of accessing the Java API online when you are developing code. In your web browser, you can simply go to this URL, or even better, just bookmark it. Or you can just Google the term Java 8 API, and the first search result will probably be the same as this one. You can also check here in Canvas, where I've added a link to the same location. But probably the easiest way when you are writing code in JGrasp is to simply go to the Help menu and select the Java API option, which will take you to this same place. The only gotcha I've found when doing this is that you must have some file open first in the editor window. But in the end, these are four different ways of accessing the one and the same official Java API. So getting back to the idea of a Java package, what is that anyway? For starters, there are over 2,000 predefined, pre-built classes in Java available for your use. These classes are organized or grouped by functionality into what are known as packages. All of these classes within these packages represent user-selectable extensions to the basic Java language. As we see here in this diagram, the core Java language is at the center, and all of the classes and packages of the Java API are available as needed to extend the capability of the core Java language. Now, some of these classes are automatically available to us in our programs. For example, there's a package called java.lang, which contains common classes such as string and math. Any such class which lives in the java.lang package is automatically available to us with no action required on our part. However, most other classes within the Java API must first be imported in order to be used. What we mean by importing is making an explicit statement that we want to pull in some specific other outside capability. If you're familiar with the C programming language, this is similar to a pound include statement. We'll show how to import a Java class in a moment. In these coming video lectures, we'll be going over a number of such classes which need to be imported. These include ones such as the random class, various data type wrapper classes, I/O classes, formatting classes, and a number of others. Once you've accessed the Java API by any of the means already presented, if you click on the All Classes link at the top left, you'll get a full scrollable alphabetic list of all available Java packages and classes. If you click on any individual class name, you'll pull up its specific class API. In the API of any Java class, you'll typically find the following things: the package address of the class, which is sort of like the full directory path in an operating system, the formal interface description of the class, some commentary on the class and possibly some examples of using it, a list of all available constructor forms, a list of all available class methods, or at least all the public ones, and the details of calling all of those methods. All the Java API documentation that you'll see is a very nice example of Java's automatically generated documentation using the JavaDoc style comments we've mentioned in an earlier lecture. Let's take a look at a specific example of a Java class API. There may also be a demo example in this week's lecture materials on accessing and navigating the Java API. Here's an example of what a Java API looks like for the string class. If I click on this All Classes link at the upper left, I can get a full alphabetic listing of all available Java classes. If I click on the java.lang package here, I can get a subset of the classes found in that package, one of which is the string class. And notice, of course, that all these class names begin with a capital letter. If I click on the string class, here is the API for the string class in Java. We see that this class's full name is java.lang.string, and here is some description of that class. And if I were to scroll down a bit, I'd come to the list of constructors for the string class. Note that there are many alternate or overloaded constructor forms, but the two constructor forms we've presented already are highlighted here, this being the default constructor and this being the constructor form which takes a simple text argument in double quotes. Don't worry, we won't concern ourselves with any of these other constructors in this course. And if I continue to scroll down, here is the beginning of the list of all available methods in the string class. Again, there are way more methods here than we can hope to cover in this course, but here are two methods which we have already seen. Here is the charAt method, which returns the character found at a specific string index, and here is the equals method, which tests the instance variable equivalence of two string objects. Note how all of these entries provide the calling interface, the method return type, and a synopsis of the method. If we were to click on any method name here, we would drill down to even more specifics on any of these methods. Go ahead and try accessing the String API on your own now, so that you can see for yourself how to do it. If you explore the Java API to any degree, you'll quickly realize that there are many packages of Java classes available for your development use. All packages group related classes together according to functionality. Here are 5 common Java packages which we'll be using in this course. These classes shown in blue are the ones which we'll be covering in the very near future. The java.lang package contains lots of basic functionality, in particular the string and the math classes. Note that this is the one Java package that is automatically available to us without having to explicitly import it. The javax.swing package contains numerous components used to build graphical user interfaces. We'll be taking a look at the JOption pane class specifically, which provides pop-up input-output dialogues to our programs. The java.text package contains classes useful in formatting various types of data, and we'll examine these formatting classes. The java.util package contains various useful utility classes, such as scanner for obtaining keyboard user input, and random for random number generation. And the java.io.package contains various classes needed to read and write to files. Again, there are many Java API packages beyond just these. I encourage you to take a look in the Java API at the list of available packages to start getting a sense of the breadth of capabilities that Java provides you. So now that we've seen that Java classes are organized into various packages, how do we make use of some external Java class in our programs? If we want to make use of the capability that some Java class provides us, we need to pull that capability into our program using the import statement. The two key things to remember are that all import statements appear outside and before any class declaration, and that we can import individual Java classes, which is often preferred, or entire Java packages. Down here at the bottom, we see examples of both kinds of import statements. Let's say that we want to make use of the scanner class, which gives us user input capability in our program. Before we try to create a new scanner class object, as shown here, we must first import the scanner class. We can do this in one of two ways. We can surgically import the scanner class explicitly using its full package address, java.util.scanner, as shown here. Or we can take a more sledgehammer approach and import the entire package in which scanner lives using this asterisk wildcard notation. But whatever we do, notice that an import statement appears outside and before the class declaration, not inside the class. I would generally advise you to do your imports this first way, because it helps you better keep track of all the external dependencies in your code and makes it easier to track all the specific classes that you are using. However, sometimes the import of an entire package does make more sense. For example, if you are doing GUI or graphics development and you find that you need a substantial portion of the javax.swing package classes. It's not wrong to import an entire package like this. There's only a minor compile time penalty, and your bytecode isn't going to get bloated up because the compiler is selective. But in the code you'll be writing for this course, I'm going to ask that you import classes specifically like this. I just find that this is a better software development practice. Okay, That's it for packages and importing for now. You'll be doing this for yourself quite a bit now as we start working with our next set of Java classes.